Welcome back, tech enthusiasts. Today, we're diving into the world of recursion and iteration. Both are powerful tools in coding, but knowing when to use each can save you time and headaches down the line. Let's start with a simple example, calculating factorial. Recursion is perfect here. It's like defining a function that calls itself to multiply all numbers from 1 to n. For instance, fact 5 would be 5 asterisk fact 4, and so on until it reaches 1. Iteration, on the other hand, uses loops like for or while to achieve the same goal. It's more like using a step-by-step process to reach your end result. While recursion is elegant and easy to understand, iteration can be more efficient in terms of memory usage. So, choose wisely based on your project needs. Hello everyone, and welcome back. Today's agenda is packed with essential knowledge on recursion and iteration. First, we'll introduce both concepts to make sure you're all up to speed. Then, we'll dive into the key differences between them, because sometimes a loop isn't always the best choice. Next, I'll give you real-world examples so you can see these in action. We'll also discuss when to use each approach and highlight their pros and cons for better decision-making. To wrap it up, there will be a quiz to test your knowledge. Finally, we'll summarize everything we've covered today. Let's get started. Welcome back, everyone. Today, we're diving into the fascinating world of recursion. Imagine a function that calls itself over and over again. This is what recursion means. It's like those Russian nesting dolls. Each one contains another until you reach the smallest piece. For example, if you're calculating the factorial of a number, recursion can make it super clean and simple. But remember, every time a function calls itself, it uses memory, so be mindful of how deep your recursion goes to avoid running out of space. Now, when do we use recursion over iteration? Well, for tasks that naturally break down into smaller subtasks like traversing tree structures or solving complex math problems, it's often more elegant and easier to understand with recursion. However, if performance is a big concern, sometimes an iterative solution can be faster and use less memory. So, choose wisely based on the problem at hand. Welcome back. Today, let's dive into the concept of iteration. In programming, iteration means repeating a process until we achieve a desired outcome. We use loops to perform these repetitive tasks efficiently. For example, if you wanted to print numbers from 1 to 10, you wouldn't want to write out each line manually. Instead, a loop does this for you. Now, when should you use iteration over recursion? Well, consider a scenario where you need to check every element in an array. Iteration is perfect here because it's straightforward and often more efficient. But what about situations where the problem itself involves recursive calls, like traversing a tree structure? That's where recursion shines. In summary, choose iteration for simple, repetitive tasks, and use recursion when the problem naturally fits into a recursive pattern. Welcome back, everyone. Let's dive into our example of recursion. Today, we're going to look at the classic factorial function using recursion. Recursion is a method where the solution depends on solutions to smaller instances of the same problem. For instance, let's say we want to calculate 5 factorial 5. Here's how it works. 5 is equal to 5 times 4 times 3 asterisk 2 by 1. In code, this looks like which calls itself with smaller numbers until it reaches the base case of 0 or 1, where it simply returns 1. This is when recursion shines, solving complex problems by breaking them down into simpler subproblems. However, remember that while recursion can make code cleaner and easier to understand, it might not always be the most efficient approach compared to iteration in terms of memory usage and speed. We'll explore more on this later in our comparison between recursion and iteration. Great job! Now let's take a look at our output for running the recursive factorial function. This slide shows us that the factorial of 5 is 120. Remember, in recursion, we keep calling the same function to solve smaller instances of the problem until we reach a base case. In this case, the base case is when the input value reaches 0 or 1, as their factorial is simply 1. For example, if you call our factorial function with an argument of 5, it will break down like this: 5 is equal to 5 times 4, and so on until it hits that base case. This approach can be very elegant but might not always be the most efficient, especially for large numbers or when dealing with performance constraints. So, In real-world scenarios, we often consider whether recursion is the best fit compared to iteration. Let's dive into a real-world example that showcases the power of recursion. Today, we're looking at the Fibonacci sequence, a series where each number is the sum of the two preceding ones, 0, 1, 1, 2, 3, 5, 8, and so on. Now, let's implement this using a recursive function. This approach mirrors the mathematical definition beautifully. Here's how it looks in code. Welcome back, everyone. In this slide, we're diving into the output of our recursive Fibonacci function. Here's what it looks like. This list contains all the numbers in the Fibonacci sequence up to a certain point. For example, if you input 10, you'll get 0, 1, 1, 2, 3, 5, 8. Notice how each number is the sum of the two preceding ones, starting from 0 and 1. Now, let's compare this with iteration. While recursion is great for problems like this, it can be less efficient due to repeated calculations. Iteration might use a loop instead, storing previous numbers in variables. Both methods have their strengths. Recursion is elegant and easier to understand, while iteration can be more memory efficient. The choice depends on the problem and your preference. Stay tuned for our next comparison. Welcome back. Today, we're diving into the world of iteration. Think about when you need to do something over and over until a specific condition is met, like counting down from 10 or printing each item in a list. That's what loops are for. Loops allow your code to repeat tasks without writing redundant lines. For example, if you want to print every number from 1 to 5, you wouldn't want to type print 1, print 2, all the way up to 5. Instead, a loop does this for you automatically. But remember, while loops are powerful, they can also be tricky, especially when dealing with recursion. Next slide, we'll explore how and why you might choose iteration over recursion. Welcome back, tech enthusiasts. Today we're diving into the world of iteration with an example that everyone loves, the Fibonacci sequence. This time, let's see how to generate it using a loop instead of recursion. Why would you use this method? Well, sometimes, especially when dealing with large numbers or performance-critical applications, loops can be more efficient and easier on your system resources. Let's take a look at the code. We initialize our first two values, 0 and 1. Then, for each number from 2 to n, we calculate the next Fibonacci number as the sum of the previous two. This way, we avoid the overhead of recursive function calls. So remember, when you're working on projects that require a lot of repetitive tasks or calculations, iteration might just be your go-to approach. Okay, let's dive into our slide on running the iterative Fibonacci function. Here we see an output of a list containing the first 10 numbers in the Fibonacci sequence. Now, you might wonder why we chose to use iteration for this task. Well, in cases where performance and simplicity are key, iterations can be more efficient than recursion because they avoid the overhead of function calls. In our code example, notice how it uses a loop to generate each number based on the sum of the previous two. For instance, starting from 0 and 1, we get 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. This approach is especially useful when dealing with larger sequences or performance-critical applications. Let's dive into some common pitfalls. First up, using global variables for state can lead to spaghetti code and hard-to-track bugs. Stick with local or component-level states where possible. Next, calling an API inside a loop without caching. That's like running the same marathon every day but never improving your time. Cache responses to avoid unnecessary calls. Finally, hard-coding credentials in your source code is like leaving your front door unlocked at night. Security nightmare. Use environment variables or secure vaults instead. Moving on to recursion versus iteration. Choose wisely. Recursion shines when you're dealing with tree or graph traversals, while iteration is more efficient for loops and simple state changes. Remember, the right tool for the job makes all the difference. Alright, let's dive into this quick quiz. What's the main difference between recursion and iteration? Think about it for a second. Recursion uses function calls to solve problems. It breaks down a problem into smaller subproblems by calling itself repeatedly until reaching a base case. For example, calculating factorials with a recursive function like this, until equals 1. On the other hand, iteration uses loops to perform repetitive tasks like a for loop or while loop. It repeats a set of instructions until a condition is met. For instance, printing numbers from 1 to 10 with a for loop. So, the key difference lies in how they approach solving repetitive tasks, recursion through function calls and iteration through loops. Welcome back, everyone. Today, we're diving into the pros and cons of recursion versus iteration. Let's start with recursion. It's like breaking down a big problem into smaller, more manageable pieces, perfect for tasks where you need to repeat operations on smaller parts, such as traversing tree structures or solving problems like Fibonacci sequences. Recursion can make your code cleaner and easier to understand in these cases. However, it comes with some downsides. Recursive functions use more memory because they keep track of each call in the stack, which can lead to a stack overflow for large inputs. Now, let's look at iteration. Iteration is like using a loop to repeat an operation until a condition is met. It's generally more efficient and uses less memory than recursion. You'll find it in loops that handle large datasets or when you need fine-grained control over the process. So, which one should you choose? Often, iteration wins out for performance, but recursion shines where simplicity and readability are key. Welcome back, everyone. Let's dive into an exciting real-world example of tree traversal using recursion. Imagine you have a family tree where each person can have multiple children. In this scenario, we want to visit every individual in the tree starting from the root. The recursive approach is perfect here because it mirrors the hierarchical nature of a family tree. Essentially, we visit the parent node and then recursively call the same function on its child nodes until there are no more children left to explore. For instance, if you start with the root person, you dive into their direct descendants, continue down to their offspring, and so on. This method ensures you don't miss anyone in your family tree traversal. Great job! Now, let's see what our recursive function does. We've defined it to traverse the tree and return a list of nodes in tree order. When we run this function on our tree structure, you'll notice that it visits each node following the depth-first traversal method. For example, if we have a simple tree with nodes A, B, C, D, E, where A is the root, and B and C are its children, followed by D as a child of B, and E under C, our function will return A, B, D, C. This order reflects how it explores as deeply as possible along each branch before backtracking. Recursive functions like this one are perfect for tree structures because they naturally follow the nested nature of trees. Alright, let's dive into an example where we'll use the iterative approach with a stack for tree traversal. This is a great way to understand when you might want to opt for iteration over recursion. Imagine we have this binary tree, 10, root, left child 5, right child 20, and so on. Iteratively, we can perform an in-order traversal using a stack. We start at the root, push all left children onto the stack until there are no more left children to process. Then, we pop from the stack, visit that node, and move to its right child. This way, we avoid potential issues with recursion like exceeding the call stack limit for very deep trees. It's a bit like a real-life treasure hunt where you go as far left as possible, then backtrack and explore the right side. Okay, let's dive into the iterative version of our tree traversal function. This function takes in a tree and returns a list of nodes in tree order, meaning we visit each node exactly once as if following a path through the tree. In contrast to recursion, which relies on calling itself, iteration uses loops like a for loop or while loop to traverse the tree. For example, imagine we have a simple binary tree with nodes A, B, and C. Our function would start at the root, let's say it's node A, then visit its children in order, effectively creating our list. This approach is great when you're dealing with large trees or when you want to avoid potential stack overflow issues that can come with deep recursion. Welcome back, everyone. Let's quickly recap what we've learned about recursion versus iteration. Both are powerful ways to solve problems in programming, but they work a bit differently. Recursion is like solving a puzzle by breaking it into smaller, similar puzzles. Think of it as calling a function within itself until you reach a base case, kind of like peeling an onion layer by layer. On the other hand, iteration uses loops, for or while, to repeatedly execute a block of code, like using a drill to make holes in wood over and over. Which one should you use? Well, if your problem can be broken down into smaller problems that look similar, recursion might be the way to go. But for simple tasks that repeat until a condition is met, iteration often gets the job done more straightforwardly. Alright, let's put your knowledge to the test. When should you prefer iteration over recursion? For starters, think about problems that can be solved using loops. Iteration is often more straightforward and efficient for tasks like traversing arrays or linked lists. Plus, it avoids potential Stack Overflow errors in deep recursions. Imagine a recursive function diving too deeply into calls, running out of memory space. So, for situations where you need to keep track of elements step by step without the risk of hitting that recursion limit, iteration is your safer bet. Ready to put this into practice? Let's dive into some coding examples next.